The Lewis structure of a larger molecule of sulfuric acid. Lewis structure of sulfuric acid. Now, up front, I can tell you with period 3 elements, which include aluminium, silicon, phosphorus, sulfur. Those ones tend to have more than 8 electrons around them. And you need to know that, because sulfur here is gonna take 6 bonds for you to get the most favorable electronic configuration. Because sulfur is in period 3, then it can take more than 4 bonds around it. Alright, anyway, let's follow our baby steps. So we have to determine the number of valent electrons. So you have 2 hydrogens, you have 1 sulfur, and you have 4 oxygens. So it's number of valence electrons. Each oxygen brings 6. So you have 2 plus 6 plus 24. Total number of electrons, 32 electrons. Alright, so it's 32 electrons total that we need to account for around the atoms in the Lewis structure. So that said, now you need to arrange the atoms in space, the sulfur, oxygen, and hydrogen atoms in space, elements in space. Okay, so now we should put the least electronegative atom in the middle and the hydrogens in the terminal. So sulfur here is the least electronegative compared to oxygen, because hydrogens needs to be outside the structure. So now we're gonna put hydrogen outside, then sulfur in the middle. Since we have 4 oxygen, they can go in between, because we know one of the minor rules that we follow is each time you have hydrogens in a structure, you need to accompany them with the oxygen if oxygens are available in the molecule. Okay, or if nitrogens are available in the molecule, hydrogens will go with the nitrogens or hydrogens go with the oxygens. So the 2 hydrogens will pair up with 2 of these oxygens. That's why we put this structure like this. Next step is to assign electrons in between them to form a bond, because the atoms cannot just freely hang in space. We've used so far we've used 1, 2, 3, 4, 5, 6, 12 electrons. We should be left with 20 electrons to account for. So since hydrogens are happy, you have a duet there, you have a duet here for the hydrogen, 2 electrons, and the sulfur is happy, is an octet. Only the oxygens are not happy, because this oxygen is lacking 6 electrons, this oxygen has 4, it's lacking 4. So this oxygen has 2, it's lacking 6, and this oxygen has 4, it's lacking 4. So out of these 20 electrons, we're gonna spread them, making octets, these oxygen octets. Okay, so we're gonna make our oxygen octet here by adding 4 electrons, here by adding 6 electrons, here by adding 4, and here by adding 6. Counting all those electrons now, 1, 2, 3, 4 should be 32 electrons, but this is not the correct structure, Lewis structure, because now the formal charges here are not gonna be 0 for this oxygen, and for this oxygen it's gonna be -1 for this one, -1 for this one, +2 for sulfur. Just a review on how to determine oxygen or formal charges. We're gonna, well, before doing the formal charges, let's draw other possible Lewis structures for sulfuric acid, and that's possible by pushing the lone pairs in between oxygen and sulfur just to try and form a double bond, right? So you could push this lone pair inside, you should end up with this structure. You'll be left with 2 lone pairs outside and 4 bonding electrons in between. So that will give you this hybrid structure, and this is just resonance. That's how I'm using the resonance arrows here to show this is a hybrid of that and this is a hybrid of this. Then you push, you can do the third structure by pushing this lone pair inside to form 2 bonds there, 1 pi bond and 1 sigma bond, so you end up with this structure. Now, out of these 3 structures, which one is the correct one? This should be the correct one because it gives the atoms formal charge of 0, and the best Lewis structure out of a set of possible Lewis structure is the one that has values close to 0 or 0 as much as possible. And just a review of calculating Lewis structures. These are the 3 possible Lewis structures. This should be the correct one. So the formula for calculating formal charge is given by the number of valence electrons in a neutral atom minus non-bonding electrons. Those are the number of electrons in the lone pairs that are not forming a bond, minus half the bonding electrons. Remember, a bond is 2 electrons. So for the oxygen labeled A, you have 2 bonds. That means you have 4 bonding electrons. And you have 2 lone pairs. That means you have 4 non-bonding electrons. And you know oxygen is in group 6, so it has a valency of 6 in the periodic table. So doing the math, you should get the formal charge of this oxygen here to be 0, which is this equivalent to this oxygen, because the molecule is symmetrical anyway, gives you 0. Okay, also for this one. So for B is the same thing, you get a 0. For sulfur, has a valency of 6, has no lone pairs on it. You see there's no lone pairs. Then it has 12. For this hybrid structure, it has 6 6 bonds, so that means it has 12 electrons, because each bond is 2 electrons around sulfur. So the formula will be 6 minus 0 minus half of 12. You should get 0. Okay. For the hydrogens, each of these hydrogens has a valency of 1. There's no lone pair of these hydrogens, so it's 0. And then each of these hydrogens have 1 bond. 1 bond is 2 electrons, so it's 2 electrons. So 1 minus 0 minus half of 2, you get 0. See, all the atoms here have a formal charge of 0, so that's why this is the best Lewis structure of sulfuric acid. Why are the rest of the 2 structures wrong? You do the same math. For oxygen A would be valency of 0, oxygen B would be valency, you do the same thing for oxygen A, you have a formal charge of 0, same with oxygen B, and sulfur will have a +1. Why is it so? Because sulfur has a valency of 6 with no lone pairs on it, so it's 0, and then it has 5 bonds around it, so those are 10 bonding electrons. You should get a formal charge of +1. The hydrogen is gonna still have a formal charge of 0, while the oxygen C, this oxygen here, has 6 non-bonding electrons, and it has 1 bond, 2 electrons. It has a valence of 6. The formal charge is -1. So you see, you have a problem here. You have sulfur with a formal charge of +1, and oxygen with a formal charge of -1. Those are not as good as what you can have in this structure, so this is out. Same thing with this, you have oxygen B and C having formal charges of -1 and sulfur having a formal charge of +2. That cancels, makes this structure wrong. So the right formal Lewis structure of sulfuric acid is this. I hope that explains why the Lewis structure of sulfuric acid is this and not this one as initially found in the first slide. Thank you, Teacher M here again. For more videos like this that explains everything in detail, please subscribe down there, ask questions, and I should be back to you as soon as I can. Take care.